Hey guys, good morning. Today, we will learn about capacitor bank switch restrikes. It's also, surge voltages happened, when we switch on and off the capacitor bank. But as you guys know, we've been learning like LC circuit, right? And because of different energy source, they have to be the like a vibration or like a swing, right? But generally it cannot over two times of the magnitude itself. It cannot over two times of swings. But sometimes because of some element or some of facts, it make a more high surge, like almost four times like that. So this is the example of of over two times of switching surge. You know what I mean? So yeah, we will learn about it today. And as you guys know that generally our power factor is is pager is almost one. You know what I mean? But like fault current or short or this time happened the power factor, you know what I mean, between the voltage and current phase difference is gonna be like almost 90 degrees. It makes a more higher surge. So we will learn about it. Let's see it. Yeah, I will explain. Give us a guys. Yeah, here guys. First of all, our power system is from the AC source, and there's RLC circuit, right? But today, what we learn is when you open the capacitor bank, you know, when you fully charge it, you know, so we will learn about it, what happened. So for example, here, I will say A point, first part, and the second part is B point, okay? So first of all, so this green line, I will say, we start opening, open the circuit, capacitor, open the circuit from here. So what happened? First of all, uh, as you know, current is not in the same pace. It should be differences between around 90% leading or lagging. It doesn't matter. Okay. By the way, now the matter is it's uh, between the voltage and the current power factor is not one, almost 90 degrees differences. So for example here, capacitor current is flowing. So as you guys can hear, but if we open the circuit, this point, but as you guys know, current has it disappeared at the current 0 point here, right? So it needed time, right? As I said, we don't, I mean, L or the C, it doesn't allow to them like a sharp, sudden change, sharp change is fine, but what I mean, sudden change of from, from 0 to the 90, it cannot change like that. It make it like a smooth, you know what I mean? So that's why it needed like the current is display here, we will say 0 point, current 0 point. But look at that. What I mean is here, this black line is a capacitor, I mean, bus voltage. You know what I mean? Bus voltage, for example, this source voltage, right? So, which color is, yeah, it's purple. So if it's, the bus voltage is coming through, right? But this point, look at that. At this point, the current is disappeared, right? But look at that here, A point. A point is it follows the bus voltage, right? Because it's connected, right? But this is open. So A current is like this is following the bus voltage or source voltage. But the matter is the B point, it already charged capacitor voltage here, this part. So which means between them, there's voltage differences. Look at that here. It capacitor, it has it stored energy here, right? So it continuously going like this. You know what I mean? But the matter is here. Look at that. But as you guys can see here, bus voltage, when it goes to the half, half of a period, right? This is one period. But when it go to the after this period, the current, and then between and after half of a wave, between capacitor A and B point, you know what I mean? The big dip, or because of the voltage differences, you know what I mean? So it could cause, insulation damage or dielectric damage. So reactors happened, you know what I mean? So as you guys can see, Arcus is, as I explained, actually it's a plasma, but what I mean is it's a flowing the conductor, you know what I mean? When the Arcus exists, the current is also could, follow, when the Arcus exists. So I will say fluid the conductors. I will say the plasma arc, you know what I mean? Same meaning. So as you guys can see here, LC, it gotta be, you know what I mean? It gotta be the connected one circuit, you know what I mean? Because of the arc. It's happened here, right? And then it's connected. But the source voltage, A point is bigger than this B point. So it observe or it follow this circuit, you know what I mean? But because of the LC circuit, it cannot, no, it gotta be happened the swing. Look at that. So from here, it gotta be like this. You know what I mean? So this time, almost 3 times, or 2 times, we say the surge voltages happened. So we will say this is a restrike occurs because of the voltage differences between A and B, point. You know what I mean? Because reactors happened. You know what I mean? Because of too high voltage. And then if we cannot, so the method is after then also here's also store energy here, like no. So from here, it also store energy here, like this point, the A point, right? And the method is also the voltage is also flowing like this. One part is, storing here, but one part is here, like you can see here how many times. So this is we say we gotta consider and be careful of when you open the capacitor bank. Restrikes happened, but because of the in the circuits R's resistance and the damping operation, so it cannot be like over like 5 times or 6 times. But generally, we say between 3.3 times or between 4 points, surges, surge voltage, it could be happened because of this LC's swing impact, you know what I mean? And because of the capacitors, it just stores energy, you know what I mean? Yeah, today lecture is yeah, done, guys. You know what I mean? Yeah, if you guys have any question, let me know. That's our today lecture.